Hello, my little warriors. I'm back again on another video on CBSE Class 10 Real Numbers chapter. Here in this video, we shall see the Theorem 1.2. And I'll tell you, many of the kids they don't understand the working given in the textbook, and because in the textbook they simplified the solution without giving the real examples. Okay, here I'll try and explain this theorem with examples. Hopefully by the end of this video you will be able to understand this theorem clearly. Okay, now let's dive into the theorem. The theorem says, let p be a prime number. It says, let p be a prime number. It doesn't say p be any number. It says p is a prime number. Prime number means p will be 2 or 3 or 5 or 7 until infinity. It can be any prime number. And then they say, they are given it. If p divides a square, then p will also divide a. Okay, what is the meaning of that is, let's for simplicity's sake, let's take a is equal to 6, 6 and a square will be 36, and we'll, for an example, we'll take p is equal to 2. So as per the theorem, they say if p divides a square, that means a square is divided by p, you get an answer. Then as per the theorem, a also will be divisible by the prime number, you will get an answer. If this condition is satisfied, then this condition also will be satisfied. That is the meaning of this particular theorem. Now let's substitute the values of p and a in this example and see whether you are getting an answer. A square is equal to 36 by p, 2 will be equal to 18, you are getting an answer. And a, which is 6 divided by 2, you are getting 3, also an answer. Now instead of p is equal to 2, we'll take p is equal to 3. So 36 by 3 will be equal to 12. Still you are having an answer. And 6 by 3 will be equal to 2. You are having an answer. So the theorem is satisfied. Now let's take a value 4. 4 is not a prime number. It's a composite number because it has got more than two factors as more than two factors. Any number which has got more than two factors is not a prime number, then it is a composite number. So 36 divided by 4 will be equal to 9. Yes, 36 is divisible by 4. But will 6 be divisible by 4? No, because you get 3 by 2 and it's not divisible. Because 4 is because 4 is a composite number. 4 is not a prime number. Let's take another one. P is equal to 5. Will 36 be divisible by 5? No. So if this is not satisfied, then it won't, p also won't be divided by then a also will not be divided by p, that is 6 by 5 also will not give you an answer. So this is the actual meaning of the theorem. Now let's dive into the theorem working in the textbook. In the textbook they are given as a is equal to p1, p2 until pn. Now we'll take here a value as 12. You can ask, why sir, here you took a as 6, here you are taking 12, just a different number. Okay, it does not matter, you can take any number. I'm taking 12 because I'll get three factors in this. Okay, so when I want to find the prime factors of 12, you'll get 2, this is 3, 2, 3, 3, 1. So you get p1 is equal to 2, p2 is equal to 2, and p3 is equal to 3. So 12 will be equal to 2 into 2 into 3. Okay, this is the meaning of what is given in the textbook. And as per that, a square will be equal to 12 square, which is equal to 144, which is equal to 2 into 2 into 3 the whole square. That is what is given as uh, p1 square, p2 square, and pn square in the textbook. Now here comes the interesting part. Okay, we have taken a is equal to 12, and the factors for 12 is 2 into 2 into 3, and a square will be 144, and the factors for 144 will be 2 into 2 into 3 the whole square, which will be equal to 2 to the power 4 into 3 to the power square. Okay, and we will take p is equal to 3. Now to understand the next part of the theorem, let's go directly into the theorem, and then I will explain from the theorem itself. Okay, and the theorem says if p divides a square, if p divides a square, what we have taken p now here, p as 3 and a as 12, and a square will be 144. So factors of 12 will be 2 square into 3, and factors of 144 will be 2 to the power 4 into 3 square. Okay, now they say if p divides a square, then by here also say if p divides a square, by fundamental theorem of arithmetic, it follows that p is one of the prime factors of a square. What is the meaning of that is, if p divides a square, if a square is division is p is dividing a square, then by fundamental theorem of arithmetic, one of the prime factors of 144 will be 3. That is the meaning of this. So if you check the factors of 144, they are 2 to the power 4 and 3 square. So you have 3 here. So one of the factor of 144 will be p, which is 3. Okay. Now the next part of the theorem says, by using the uniqueness of fundamental theorem of arithmetic, as per fundamental theorem of arithmetic, when we use the uniqueness of the theorem, then this 144, whatever prime factors it has got, 2 power 4 into 3 to the power 6, 3 to the power 2, this can be written only in this form. This can be written only in this form, and this form will not be repeated in any other number. That means this 2 power 4 and 3 square is unique to 144. Okay, that is the meaning of uniqueness part of fundamental theorem of arithmetic. We realize the prime factors of a square are 144, a square are p1, p2, and p power pn. Okay, so 144, which is a square is equal to 144, and the prime factors of that will be 2 into 2 into 3. That is the meaning of this. Okay, so then we have p as 1 here, this part of the question. P is 1 of p1, p2, p power n. So p is 1 of p1, p2, and pn. Therefore, the theorem, as per theorem, a will be also be divisible by p. Therefore, a will also be divisible by 3. This is the meaning of this particular theorem. Okay, if you want, I'll explain this part again. Okay, if as per the theorem they say, if p divides a square, okay, p divides a square, then by fundamental theorem of arithmetic, p will be one of the factors of a square. So you can see in 144, 3 is one of the factor of a square. And also by the uniqueness of the fundamental theorem of arithmetic, 144, if you want to write the prime factors of 144, that will be only this particular factor will not be repeated to any other number, also will it will not be divisible by 5 or 7 or 9 or any other number. If you want to find the prime factors of 144, it will have only this as the answer, 2 power 4 and 3 square. And this 2 power 4 and 3 square are basically the prime factors of a square, which is basically 2 into 2 into 3. That's how we prove that a will also be divisible by p. Hope you understood the working of this particular problem, and if you have any doubts, let me know in the comment section. I'll be glad to explain this, okay? Because many of the kids, they understand, because in the textbook they given it without any example. If you understand with an example, then it becomes much clearer. That is why I tried to explain it with, because this particular value, you can take any other values, you can take any other values, still you are going to get the same answer. So this is theorem 1.2. Hope you understood. Now see you in the next video. Thank you for listening, guys. Bye bye.